All right, so in both of the containers, both the little plastic bag and in the Florence flask, you saw what you were looking at were the growth of crystals in there. Right? And so it's evidence that what is in those solutions, and both of those are simply sodium acetate, okay, and it's been dissolved. And if you remember, sodium acetate, what class of chemical is this? Huh? Well, this part is a hydrocarbon, but because we put this on here, this is ionic. This is a polyatomic ion here. You need to know that this is a polyatomic ion, right, Kayla? You need to know this is an ion.
That's Kayla.
I'm sorry, Kayleen. Quiet, please. Okay, this is an ionic compound. If we take this and we dissolve it, okay, what does this stuff actually become when it's dissolved?
A crystal.
It's not a crystal when it's dissolved. It's a crystal before it's dissolved.
Right. It becomes a liquid, duh.
Okay, but what form does it take in a liquid when it's dissolved?
Liquid.
Separate ions.
Right.
Okay, think back to the unit where we wrote those complete and net ionic equations.
Like the first part is...
This is a crystal where there are millions of sodium and acetate ions linked together in a large crystalline form, a lattice. Okay? When you put it in water and you dissolve it, these ions actually separate. So instead of actually having sodium bonded with acetate, instead of actually having those bonded together, they're no longer bonded together. They've been solubilized. Okay? And so what they actually are sodium ions. This is just like writing the net and complete ionic equations, and acetate ions. All right. Anytime you dissolve any ionic substance in water, there's a point where you can, well, I shouldn't say any. There's usually a point where you can't dissolve anymore. So the three solutions we're working on over there back in the corner, we have magnesium sulfate and sodium chloride and calcium chloride. We are trying to get the solutions dissolved to the point that I can't dissolve anymore. Okay?
How do you know what that point is?
When we start seeing solids at the bottom that don't dissolve. We haven't reached that yet, right? Is there any solid that hasn't dissolved yet? So we're not at that point. Now, so these liquids are not yet saturated. Okay? Right now, those three liquids over there are unsaturated. Okay? Unsaturated because they haven't reached the point where I can no longer dissolve anymore. So we got the term saturated, we have the term unsaturated, and when we're talking about solutions, you need to know that an unsaturated solution is one that you can still dissolve more solute into. Okay? A saturated solution is one where you can no longer dissolve any more of the solute into the solvent or solution. But what we did with the demonstration there with sodium acetate is we supersaturated it. Supersaturated it. Okay?
Are we talking about this?
We're talking about a bunch of different things here. We've got 4 different solutions in this room we're talking about. Okay? We have the 3 solutions over in the corner. Wrong one. We have the 3 solutions over in the corner here that Tom and I are working to try to get completely saturated. They are not saturated yet. We can still dissolve some more salt over there. Okay, Tom, if you don't mind, go over there and put some more salt in that calcium chloride and that magnesium sulfate. We can still dissolve some more. Okay? There's still room over there to put more.
The solids forming at the bottom. If there's no
All right.
solids forming.
You know,
Oh,
if
it's full and we add more, then it's just going to sink to the bottom.
oh,
okay, if it's saturated, then if I put any more in there, it settles to the bottom and it doesn't look like anything's being dissolved. Okay, now remember that term, look like, because look like doesn't mean that's what's happening. In fact, the word we're going to title English in here. Okay, when you say the word like, it excludes the class you're talking about. Okay, so if I say something looks like something else, it means it just appears to be, but it isn't. Does that make sense to you? If I say, now sort of an opposite term in that sense is such as. If I say such as, it includes that term in the class I'm talking about. What we're talking about here is it looks like. So, okay, so he's putting more of these salts in those containers, and in a few minutes it'll be evident. Well, the sodium chloride is a little cloudy; it's kind of hard to tell it. But the others, they get clear, and all the little solids are dissolved. Okay, at some point we'll have so much of the solids in there that we can't dissolve anymore, and we start getting solids settled at the bottom. Okay. So if we're at the point where we can still dissolve some more solid, it's unsaturated. Okay, Jay Breezy, pay attention here. If we're at the point where we can still dissolve some more solids over there, the liquid or the solution is unsaturated. Once we reach the point where we can't dissolve anymore, that's called saturated. And then what we did for this demonstration earlier is supersaturate the solution. So in a sense, we kind of tricked the solution into accepting more dissolved material, more solute than it would normally accept under normal conditions. And that's what supersaturated means.
So are we getting those supersaturated?
No, we cannot. We're not going to be able to supersaturate those. Okay? Well, only certain substances, you can only supersaturate certain substances. Sodium acetate's one that you can. Those salts over there, we're not going to be able to supersaturate those. Okay? We're doing a different demonstration with those. All right. So what I did was I reached the point of saturation with our two demonstrations here in two different ways. One way was to initiate crystallization. To initiate crystallization, starting with a crystal. So in the Florence flask, I simply dropped a crystal down into there, and it started all the supersaturated sodium and acetate ions, started them linking together. Okay? In a sense, it sort of catalyzed that crystallization. But it wasn't a true catalyst because the catalyst is not used up in the reaction. That crystal was actually used up. So it started the reaction. Now, in your hand warmer, what you did was you created a kind of shock wave. And the shock wave from snapping the little button inside initiates the beginning of the crystallization. And you can see it starting to grow in there. Okay?
That's just crazy.
Yeah. And now, we're in a solutions unit, and we're not yet in the unit where we're going to discuss thermochemistry. But this is hot, as you noticed. And what's happening is we are bonding sodium and acetate ions together. And when they bond together, they give off heat. All right? And so when we get to Unit 10, when we talk about thermochemistry, I want you to remember that. Because this is showing, this is also a demonstration that the formation of bonds is always exothermic. The formation of bonds is always exothermic. Breaking of bonds is always endothermic.
So what's in the little chip?
Absolutely nothing. It's just a piece of metal. By snapping it, you start a shock wave that bangs some of these ions together and starts the crystallization process. That's all that's happening. Okay? All right, so supersaturation then, you need to know what that is. And it's in your unit handout. Okay, we just demonstrated it. I just told you what it is. You need to know those terms. Unsaturated, saturated, and supersaturated. Okay? Everybody got it? Those solutions over there are, which one of these three? So far they're unsaturated. Y'all look over there. Anything? Does any of them look like they have anything that's not dissolving now?
I can't really tell.
Well, the sodium chloride's a little cloudy, but the others look like they're pretty much dissolving, aren't they?
The one in the middle is
That one's the one that's cloudy, and it's kind of hard to tell.
why is the one on the right brown?
It's just, I don't know. There's some kind of contamination in there. It shouldn't be like that, but it is. All right? Because it's not, pure, really, really pure. There's probably something in there that I don't know what it is. Okay? It's not, I bought the stuff from a department store. It doesn't have to be really, really pure for the purpose it's designed for. So there's probably some contamination in there. It's not pure calcium chloride. Okay? All right.